All right, let's go. So, welcome everyone. I'm Daniel from THEO. I'm working here as a mobile team lead and also responsible for the Flutter SDKs. And yeah, most of the cases I always work on something. So if you're interested on my side project, side journey, you can find my small organization called TweakTech on LinkedIn, and you can follow all the magic that's happening there. A little bit about THEO technologies. Yeah, you will hear about the Flutter SDK today that we are building, and that's also part of our goal because we would like to empower our customers to have online streaming experiences really easily brought to their customers. We try to focus on developer experience and build something that's really easy to use. You just drag and drop. You have similar APIs on all the platforms, and you can go to market pretty fast. And then, yeah, you can see Adobe logo up there. It's just a fresh in the news. I think it happened a few months ago that we were acquired by Dolby Digital. So THEO is part of the Dolby Laboratories group now. If you would like to follow our journey and you want to hear more technical stuff from us, we do at least twice per year a TheoCon meetup, where we share our experiences, what we work with day to day. So if you're interested, you can join to the meetup group from the link. All right, so for the Flutter SDK, why we started to build the Flutter SDK, it's basically we checked what's there on the market, and then we realized that the current offerings are not really complete. So if you want to do streaming video online, then it's still difficult. There is a video player package, for example, from Google themselves, the Flutter package. There, for example, you cannot play streaming video on the web, but on the MP4. Maybe nowadays they try to change it, but at the time when we started to build the Flutter SDK, that was an issue. There are other packages which are way more advanced, but they don't support web, for example, or they don't support some certain features on iOS or Android. So we decided to let's bring our THEO packages, THEO SDKs. We have an Android, iOS, and Web SDK, and many more, but mainly these three, which are really good and they provide seamless player experience. We decided to bring this to the market under a Flutter umbrella, basically, so customers can build an app pretty fast. They just use one single code base, and the outcome is three platforms, three applications immediately on web, iOS, and Android. I will talk about a bit the current architecture of the SDK, so you will see some code, how it's implemented. And I will also talk about limitations and issues we face during development. And then it could be something useful for you when you start bridging different SDKs, different native platform code into Flutter, because yeah, we suffered a lot with some things. So the Flutter SDK itself provides a TheoPlayer component, what you can see on the right. Where basically the customer just drops that component into their application, and under the hood we start initializing our own logic, and it creates a TheoPlayer view, which is an abstraction around web, Android, and iOS, and those underlying views will just pull in the Web SDK, the Android SDK, and the iOS SDK natively from CocoaPods, Maven, and NPM. How usually works bridging these three SDKs for Flutter, it's through platform interfaces. You can also do it without platform interfaces, but then you will have all the if-else's in your code, that if iOS do this, if Android do that, and then if web do something else. If you use platform interfaces, then you can hide this logic behind one single API, and then from the moment you build the SDK for a certain platform, it will just resolve to the right one. So you don't have to have all the if-else's around platforms checks. So this is an example how TheoPlayer gets initialized under the hood. Basically, we have an abstract TheoPlayer platform class where we provide two methods. The initialize which need it for some asynchronous operation, but the most important part is the build view that will really build the native equivalent for the Flutter view. After you define your interfaces or your abstract layer, you can go platform specific. So this is an iOS example where you can see that the initialize view will do nothing because it's not needed, and the build view method will build the iOS specific UI kit view, which will which will pull in the native iOS TheoPlayer basically. And what you see there is the important part is the view type, because that's the identifier that the native code will use to know that, okay, I have to make a TheoPlayer view. The rest is just the configuration. So that was the Flutter side. In the native side, in Swift, basically you will see also a TheoPlayer plugin, which makes sure that the TheoPlayer native views getting initialized. So you can see at the bottom of the first screenshot that we register a TheoPlayer native view factory for the same identifier that we used in Flutter. So from the moment you create a UI kit view in Flutter, that will under the hood call into this plugin, and then the TheoPlayer view factory will just create the native TheoPlayer. And then this is just a screenshot for the view factory, which, as you see, always every time that gets called, then it creates a new TheoPlayer view. And in your application, this is obviously just called once at the time that you create one TheoPlayer. So how you can use this? So after you have all the abstraction, you built out your native views, then when you have to use the widget itself, you can just call TheoPlayer platform.instance, and then the methods which are available, the abstract methods, the initialize and the build view, and these will build the under the hood calls for web, iOS, and Android. And then from this moment, whoever imports this view in their view hierarchy, they will get the relevant TheoPlayer relevant to the platform. So how it all comes together. So from the moment you build up all these abstractions, it's suggested to structure your package in a similar fashion. So Flutter TheoPlayer SDK is basically the main package that contains the public APIs. So customers will interact with that one. The SDK, Android, iOS, and web, those are containing the platform-specific code, and the platform interface has the abstraction and the common methods. So basically the import chain is that you have a platform interface that gets pulled by the SDK, web, iOS, and Android, and those three gets pulled by the TheoPlayer public package. And then once you have these structures, then basically in your main package YAML file, when you build a plugin like TheoPlayer, then you have to specify for the platforms that your plugin will use that please take the Android part from the Android package, the iOS part from the iOS package, and the web from the web package. And within each of those packages in your package YAML file, you have to say that which class is your entry point. And from this moment, the framework knows that I have to call into that class, and that class gets registered. But I would like to also talk about a bit what native views we use, because Flutter provides you platform views to access underlying code. So on the web, there is only one choice, is the HTML element view, basically where you can wrap your HTML element and you are good to go. On iOS, we use the UI kit view. That's a platform view, and that has really great performance. It runs everything pretty smooth, supports DRM, so you don't have any issues. There is also another way that you can use a texture, where you can ask your native iOS code to directly draw to a Flutter texture. That's an option, but it's not necessary. However, on Android, you can see that you have multiple ways to render a native view component. So you have Flutter's virtual display, hybrid composition, texture layout, hybrid composition, and the texture. If you get the slides, you can click on the Android link, and then you will see all the descriptions of these things. all of them has issues, so you have to pick carefully which one you want. Initially, we started to go with the hybrid composition because that was a platform view that worked pretty well with surface views, because TheoPlayer renders the video in a surface, and that was the one that could do it way better, but that had performance issues on lower end devices. Then you started to go to the texture layout hybrid composition, and that didn't work on other platforms. Sometimes it showed black screen, didn't support animations well. So at the end, we had to end up with the texture itself, where you can basically, we implemented a new API in TheoPlayer Android, where you can say that instead of TheoPlayer building the view itself and start drawing, you can provide a surface to TheoPlayer, and then that will do the rendering. And in this case, you can provide a Flutter texture into TheoPlayer, and it will directly draw there from the native side. So where are we today with our SDK? What we support, what we don't, what are the limitations? Yeah, we support Android TV, iOS, and the web. We cannot support tvOS because it's just not supported by the framework itself. There is a custom fork available where you can try to compile to tvOS. I haven't tried it yet. I heard it works pretty well, but you just have to make sure that the gesture navigation and the other stuff is working. So that's something, if it works, then you have it for free, basically a tvOS integration. The other interesting story is smart TVs, because in theory we can cover all the smart TVs with our web SDK. So if you compile Flutter for web and you put it on a smart TV, it should work. However, that smart TVs has different WebView versions. So let's say a Tizen 4 TV or a WebOS 4, it's not the same Chromium version that a Tizen 6 or whatever versions are there nowadays using. And unfortunately, Flutter, the SDK itself, they don't support lower Chromium versions. So you can still compile the SDK, it's not a problem, but from the moment you put it on the TV, you can see some weird things that, I don't know, this browser API is not there, then you have to polyfill it. Then, the way how you do a for each, that's not supported in the JavaScript engine, you have to do another kind of for each and stuff like that. If you have the latest, greatest smart TV, you can just drop a Flutter web app on it and then it will work without any problem. If you go over on the support, then yeah, you start to suffer, and then you have to decide when to stop, basically. There are also custom SDKs available, especially for the Tizen TVs. The idea is similar as the tvOS custom fork for Flutter. So you can, basically these Flutter modules use the native Tizen code, but that also means we cannot use TheoPlayer Web because TheoPlayer Web is not using the underlying native components of Tizen. And those are also not really stable as far as I know. And then LG also started to support recently Flutter. They start building packages. That's something could be still interesting, but we haven't looked into it. So yeah, that's where we are today. And yeah, you have to keep in mind that Flutter has the support matrix where they have currently supported versions and they have best effort supported platform versions, and that number is growing. So you have to drop at some point certain platforms because I think they stopped supporting iOS 12, for example, recently. Meanwhile, in the previous version, it was okay. Things like that. So you have to monitor that page, and then you have to know what you can support, and then what your customers can support if they use the SDK. So some challenges we faced during development. I think one of them, some of them are small things, but the other ones are pretty interesting and breaking changes. So yeah, you have to deal with the situation that what if your customers are using a different Flutter SDK version? It can be that in our package file we specify what is the minimum, but it doesn't mean they will use the minimum. They maybe use a newer one that already broke some other APIs. then yeah, you have to work around it, or you have to tell them that please decrease your Flutter version if you can. So right now we keep it in the low level, so we are still good. We don't do any Flutter specific version checks, but it's not something we will not do in the future if issues happen. We have to see. The other interesting thing is that if you have, as I mentioned, new Flutter versions, they can break things. So we wanted to release the Flutter SDK 1.0. I don't know when was it, a few months ago. And on the release day, Flutter released the new, I don't know, 3.19 or whatever was the version at that time, and it completely broke the web implementation. So we had to rewrite the whole thing. The reason why you also see a lot of Android platform views, all those types, like the hybrid composition and the others, because all of them has quirks, and Google is trying to fix them here and there. There was also a period when they broke the hybrid composition, so you couldn't use it. You had to use a lower Flutter version to compile, and then it worked, or you had to wait for the next one to get it fixed. These are things that you have to keep in mind, and if you can, then implement CDCI that can test these things. So for example, we have CDCI on GitHub, and that can run the web, Android, and the iOS tests for free. And there, for example, what we do that we pull the latest Flutter version, we run all the tests with that, and we also run the beta. So you can run them in a matrix, and then you can test against it. Also, having a decent testing requires effort, because you can test on all the different levels. You can just test your Flutter code. With unit tests, you can test the whole integration, but then you still have the native side within the Flutter package. You can also put tests there. So we decided to not do the native tests yet, because anyway we test our native SDKs on our internal pipelines. But yeah, you never know when your integration gets broken, so it would make sense to start building tests there. Also, some random things we saw is inconsistency between different platforms. So I don't know if you have used Pigeon on Flutter. It's basically you can just define an interface and it will generate your platform-specific code. And then, yeah, based on the interface, you will have a Swift code, an Android code, a Java code, or a Kotlin code. And then, yeah, the contract is basically the same between all the platforms. They don't support it for web, for example. So for web, you have to, yeah, some people argue that, yeah, you don't have to use pigeons because it just, yeah, you just write the same code. But to have decent interfaces and you try to keep your contracts, it would make sense to have pigeon support there. The other interesting thing is when you start using pigeons, it made for a single instance communication bridge, basically. So you have to make sure that when you initialize, let's say, multiple THEO players within one view, then, yeah, the messages has to be sent with a certain ID. You need to have the player ID there to understand for, yeah, each player, and then you should parse that ID. Yeah, we fixed this problem in a way that we built an extension on pigeons, so you don't have to do these things, but within the pigeon communication, within the method channel, we already prefix the things, and then it arrives only to the correct THEO player, so you don't have to do an ID check anywhere in your native platforms. The other interesting thing there that if you use the web APIs, some of them are just not available. If you start using, like, I don't know, request full screen API or request picture-in-picture API in the Flutter code, the API is just not there. So you have to see, okay, is it just because they didn't put it there, or something is broken, or can I just put it into an extension and it will work? And then if it's not working, why it doesn't work? Sometimes you have to find the balance, what to use and what not to use. Sometimes you can just call as it is. Sometimes you have to call it in a hacky way. If you look into the source of the SDK, you can see, for example, when we go into picture-in-picture, it's an interesting way of going into picture-in-picture, but that's the only way how it works. So yeah, other issues is, or yeah, it's an issue for us, but it's a good stuff for the customers, that yeah, whenever there is a new Flutter version, what if they put something out, people are happily using it, right? Because if there is like a new platform support or a new way of rendering, people just want to use it because they assume it just one click and it will work. For example, for web, you have the canvas rendering or the DOM-based rendering, and now they have the WebAssembly-based rendering. It's usually people just say, okay, I just compile my app with this target, and then everything is fine. But yeah, you have to make sure that under the hood all the packages basically support it. And then, yeah, if let's say 99% of your current web app supports WebAssembly, but only TheoPlayer is the one that's not working with it, then yeah, you cannot use it, and then you will have a slower web app, for example. So then we have to keep in mind these things. We have to monitor all the changes and try to comply with them. Other example, that the Impeller rendering engine that they use for iOS already for a while, I think it's coming to Android pretty soon. I think it's still in beta, probably. But for that engine, the texture rendering that we used, it's not working anymore. So they introduced a new API. You have to use that one. If Impeller is used, you have to use something else if Impeller is not used, for example. And then other challenges is that, yeah, when people use Flutter, you just expect, things you just drag and drop, nice widget, and it just works. So we have to invent elegant ways for our customer that you shouldn't tell them that, okay, you drop this one here, but you still have to configure 20 million stuff there. And yeah, by the way, if you need that feature, you have to go to native part of your application, and then Android, you have to still hack this code, hack that code, other stuff. So we try to come up with the best way we can to just support a Flutter level integration, and they don't have to go lower. And then one of the limitations we have also today that you cannot just pull as far as I know, you cannot just pull an npm package into your web application without a lot of hacking around it, and you have to make it like a proper npm project. So right now we always ask the customers that, okay, when you build your web application, somewhere in your index HTML, you have to put the TheoPlayer import there, because that's the only way we can pull it in. We cannot do it automatically. Meanwhile, on Android and iOS, yeah, Gradle and CocoaPods just pulls the package and puts it there without any problem. So what's next for us? It's basically continuing support for more native features. We have it in the underlying SDKs. We try to expose them. That could also mean that we can add features which are not even there in our SDK, because it was more difficult to support in SDK level, but in an app level, it's way easier to support it. And yeah, here basically Flutter acts as an app level for our SDK, so you can do things a bit easier. Then we would like to work towards a plugin architecture. So instead of having everything in one package, we want to give the opportunity to customers to just pull in packages. So if you need the Google IMA or Google Cast integration, it will be not part of a TheoPlayer package, and your package is just growing and growing and growing. But you can just say, okay, I want to import from Flutter, in Flutter, the TheoPlayer base package, and I want to import an IMA extension, and then you just hook them up together, and then it magically works. Yeah, we have to keep up with the new Flutter version, as I mentioned. So CDCI has to run continuously on the latest versions, and we have to keep in mind what new changes are coming and the APIs are getting broken. And yeah, we have to invest more on testing. I think it's in a generic term that you need it. You have a lot of moving components, and to make sure nothing is broken and not the customers will be the first one who notice your issues, you have to invest more in tests. And yeah, if you're interested, the package is available on PubDev, obviously, and you can also check the source. It's full open source, the full package. You can see how we do the platform interfaces, how we hook things together. So if you've never done before, never used platform views in Flutter, I think it's a good starting point to look at. I think that's all. Do you have any questions?